I was laughing, thinking back, a few years. I'm a graduate from the U of A. I have an arts degree in English and sociology and then an MBA. And when I started my first tech company with Dean, who's also here, he's lurking, in 1992, I don't think I could have imagined myself putting on a seminar like this. So now and again, they let somebody in the doors here at the U of A to put on these sessions, and we look a little different. But I hope you enjoy and find some value with what we're doing, because we're sure having a lot of fun. So I'll share the screen and take you through a little bit of a history and presentation about what we're up to now as a company. Feel free to put your questions in the chat. I'll try to get to them if you would like. I'm highly interruptible as well, and but I hope you enjoy learning a little bit about RunWitHit.
Before Myrna gets started, I just want to remind everyone that we also have a sign-up sheet available if there's anything you want to talk to with Myrna outside of the time of the presentation. So I'm going to post that link in the chat. She only had an hour or so available afterwards, but I believe she'll also be sharing her contact information. So if there's anything else outside of what's discussed here that you want to talk about, feel free to reach out to her. All yours, Myrna. Thanks.
Thanks, Sabina. So this is kind of where we are now, and there's a few different ways of describing it, but really we began describing it as synthetic modeling and synthetic intelligence because our pursuit was always around recreating reality. And right now we're using that capability, and we have a vast catalog of synthetic models that we've created to create all different kinds of futures for energy and for mobility, energy transition largely, and resilience. And oftentimes all of these environments are really quite interconnected. But I'll tell you kind of how we got here. So on the call is Dean as well. He's my CTO and partner in life. We've been together a very long time. And when I was partway through my MBA, we decided to start our first company together. And this was in 1992, and the internet was a year old. And during the MBA, I felt like there was a real opportunity to improve communications. And so we developed one of the first commercial software entrants in the groupware category, and it was real-time issue brainstorming, video conferencing, audio conferencing, and this was all over all of those modems that beeped and plugged into your phone lines. And anyways, it was a fantastic experience, and we were able to reach people like NASA Mission Operations and US West, and really help people figure out how they could have productive conversations. And then this led to us and our first kind of entry into the AI space, which was through a company called Neural VR. And back then everybody was like, neural, what? Like, what are you talking about? But this was a neural net and 3D visualization company, a research company that we started, funded by a gentleman in Australia who was looking for a way to use artificial intelligence to make sense of the vast construction documents in deep sea submarines construction. And that's where we started, and we started putting the two together. So did a lot of natural language processing and neural nets, and then putting that together with a visualized space. This isn't something that I think is well recognized or understood even today, but we had great success with it. And then this is kind of our third major venture that builds off a lot of what we did then and the deep tech that we developed in that company. And our third venture is RUNWITHIT Synthetics. And I think this one is we're having the most fun of all of the ventures. And it started in 2014. And we really were feeling and sensing this frustration with the complexity of digital systems, because that was our main, kind of wheelhouse and an area that we understood. And there was a lot of failures. So a lot of really big failures when very complex systems with really complex and interconnected edges with people, human machine interface and weather systems and time zones and other cloud systems and cloud infrastructure were really challenging it didn't matter how much money you spent, any team's ability to engineer and quality control and deliver some really critical systems and have them assured that they were going to work. And so we took a history that we had, and we saw, the ability to use automation and blend artificial intelligence and create these really intelligent entities around these systems so that these systems would think they were in a reality and could be fully instrumented and understood and optimized before they went to the field. And we thought this was really a profound opportunity to help people deliver the promise of technology, and even a lot of AI systems came our way. And this is not necessarily an easy thing to do in Edmonton, is to come out with something so disruptive and say, forget your testing and QA department and let's shift everything. Let's take reality and shift it all left, right till the very beginning where you're thinking about architecting these systems. So, we had to really kind of understand what it was we were doing and begin to just start saying yes. When people said to us, can you help me with these big, hairy, scary problems to do with in-vehicle device-based systems and safe and secure driving instructions to, emergency wearables, these are things that we can't solve. We have to put people out in a field in northern Saskatchewan and tell them to fall over before we can understand whether or not our system's working. And this just isn't enough for us. So we just started saying yes. And that really kind of took us into a space where if we didn't have the right pieces to evolve the right models or modeled entities against these systems, we would have to build them. And it was fantastic because we would commercialize them almost instantly, because we would be building them to surround these systems. And we got into all different kinds of aspects of dynamic geospatial entities and reactive, responsive, and context-aware environments. And one particular thing that kept popping up was these darn people and how they mess up systems. And because of our ability to model all these really diverse entities and geospatial environments and activity and movement and really unprecedented type situations, that was the keynote Gail was talking about, was the question mark, can you do Silicon Valley? Can you do Silicon Valley during an earthquake? Can you put all the people in Silicon Valley? And oh, by the way, we want to kit it out with all of the smart industrial IoT infrastructure that we're anticipating we're going to need in place. And then can you trigger that earthquake, and can you show me what the impact calculations are going to be? So the amount of infrastructure we save, the amount of fires we prevent when we can instantly shut off the electrical at the smart meter, and we can shut off any high flow gas that is flowing because of disrupted gas lines, and we can put any kind of intelligent sensors in the street lights, and we've got this battery powered mesh network. So this was a lot of things, as you get the point, that people were asking us to do. And the keynote is in about 3.5 weeks, and there's a 150-foot screen, and it's in Silicon Valley. So we want you to create Silicon Valley for Silicon Valley. And this was for the IoT World Expo. And so that was kind of our first point at which we thought we said yes a little bit too quickly, because we had really a lot of work to do to assemble a synthetic model that was geospatially accurate, that included all of the latest and relevant research about Silicon Valley, about the substrate in Silicon Valley, the building construction, the types of people that would be there at that time of the day, because they wanted to actually make the earthquake be relevant for the time of day that we were giving our keynote. And then can we, do the impact calculations, but then maybe, can you work with us to see how we would design a system that would be able to change that impact? So where we could actually look at how we could utilize our technology and build a really dynamic emergency response system. So like I say, 3.5 weeks, and we learned a lot. But what we learned was really that we could create Silicon Valley in our modeling platform, and we could put accurate individuals in. We used research from all over the world to inform reactive responsive entities that could be people at home, that could be people in their businesses. There's a college down at the bottom left-hand corner. There was the conference center. There's a variety of hotels. And we could actually trigger an earthquake of any different strength or ground movement, which is the Mercalli index. And we could look at how their industrial IoT devices and sensors were triggered and how many. We could look at the data streams from those devices. And we could see right off the bat that, that there was this enormous opportunity, because if this area of Silicon Valley was kitted out with all of this industrial IoT infrastructure, the amount of knowledge that the utility company would have would be profound compared to what the emergency responders would have and the people themselves. So I don't know if you heard a while back, but there was an artificial intelligence app that was released in Silicon Valley and in California. And there was an earthquake. This was about a year ago. And everybody was really upset because their app didn't trigger. They had actually felt the earthquake and their app didn't go off. And they were like, so the makers of the app were like, well, it didn't go off because the earthquake wasn't strong enough. But that's not the point. I think they lost their opportunity there, because the point was, for people wanted relevant advice. They were stressed because there was an earthquake, and they wanted something relevant to say, yes, there has been an earthquake. And this is what you need to do. And this is what you should do. And so in this environment, we really kind of understood that not only should the utility company have all this data, but they should be passing it to the emergency responders. They can tell where there's fire, they can tell where there's transmission poles down, so infrastructure that's endangering people. They can tell where there's gas leaks. The emergency responders should have this information, but so should the individuals. So because we got kind of good at modeling people, and we could put all of these reactive responsive individuals in, we could also track their biometrics. So they're synthetic people. So we can ask them anything. We can ask them whether they're belly buttons or innies or outies if we want to. We really can structure this population, and we can surveil them without the creepiness and get the data that we need from them. So when we built this population, we built it based on that human responsive reactive behavior that had been data tagged in research in Japan and New Zealand and China. And we could understand who might be most stressed in this situation, what they might be needing to do. Commuters are very stressed. They're trying to get home. Residents tend to just move outside of their home, but everybody wants to know, what do I do next? What has happened? Am I in trouble? How do I get home? And so we worked with the utility technology company to figure out how we could build a dynamic response system and really capture that information, use their battery-powered mesh networks that are disconnected from the typical kind of satellite or cell infrastructure in Silicon Valley, and use that to inform people very specific, locationally relevant information. Say, this has been the earthquake, you're in Mission College, there's actually a gas leak and a fire there. You need to evacuate. Here is the 5 different routes that will take you out of the area, depending on which way you need to go, north, south, east, west, where there isn't transmission lines that are down, because we know this. And then we got to measure the stress reduction right down to the difference that stress reduction can make in people's cardiac events up to 5 years after earthquakes. So all kinds of fun. So that was our kind of like, wow, here we are at Silicon Valley, and we're on stage, and There was gasps in the crowd. The people who were putting it on actually put rumble strips under the stage. So when we triggered the earthquake, the whole thing rumbled. And it was really fun afterwards because a lot of the surprising comments were people trying to figure out how we were tracking our synthetic people. So they said, are you tracking their phone data? Are you tracking their Apple Watches? And we're like, dudes, like, they're synthetic. The earthquake hasn't happened yet. These aren't real people. We can, their numbers, we're tracking their biometrics or entities. Anyways, that was just a fun aside. But really what we began to understand when we were in this environment and the people who we had a chance to talk to afterwards was that this kind of disruptive future, and this was pre-pandemic, was on a lot of people's minds. So they were building cities for the future, they're building mobility environments, they're building energy grids, they're building all kinds of aspects based on this future that they really haven't experienced yet and is very complex, and they're not sure whether or not they're building the right things. And so we didn't kind of find that there was a specific sector that we should stick to, because there's people in every sector and there's risk in every sector. And so this is when we kind of transitioned into this company where we decided, let's put everything that we have, all the modeling that we have and the systems that we have addressed in one place and keep going. Because it all matters. It doesn't just matter that an earthquake system, can minimize the impacts for buildings. If that same system can be utilized in a configuration with other systems to help people, help them survive an earthquake and thrive afterwards. And this is kind of where we are at now. So building a synthetic modeling platform where we can use all of these interconnected models, and we can very quickly create these very realistic models that are geospatially accurate with infrastructure, the people, so hyper-localized for the people, and really be able to explore emergent behavior that can react and respond to new systems that are developed and deployed into these environments, new policy, new scenarios, and we just have continued to build from here. One of our biggest first steps after Silicon Valley was with the National Research Council's support. We built synthetic Edmonton energy futures. And this was really kind of our what did we step into here kind of response, and thinking about if we were to look at the different layers of very complex city environments or regions, what did we think the most disruptive environment was? And we chose energy. And that is something that, kind of underlies all other systems and is facing this really decarbonized, decentralized, digital future that the grid was not built for. And so we thought, well, we're really good at kind of bringing that outside in, so that the people and their behavior and how they respond to incentives, and who buys an electric vehicle because their friend does, and what does that do in a street and a neighborhood, how many people are going to be plugging in, and that this might be really important to model and to be able to show to people who were looking at changing their grids or trying to understand grid risk, what might be the necessary engagement with people. So whether that's smart charging infrastructure or whether that's changing grid assets in preparation. And this is where we got to with Synthetic Edmonton. Edmonton didn't know that we did Synthetic Edmonton because we promptly got picked up into a Singapore technology accelerator, and we're able to kind of go over Southeast Asia as well as the US and Europe before I think we ever really exposed Edmonton to its synthetic version of itself. But this was really, I think, a really fundamental and good choice of ours in being able to expose and explore scenario-based intelligence for grids and grid systems, because they're facing a very dynamic future. And I think hydrogen now is one of the up-and-comers that they're needing to explore also. So that's where we're also going next, is to add hydrogen. But these are some of the examples of what we get to do with our models, is really understand and be able to characterize very specific areas for very specific scenarios, whether that's dual disasters. We won a spot in the Electric Power Research Institute's Incubate Energy Labs projects last year. And that was a demonstration project with Incubate Energy Labs. And under the scrutiny of all of the utilities in the US, as well as the world's most preeminent research institute and utilities, they asked us to produce a synthetic environment for validation of Phoenix. And they said, and we want you to synthesize all of the grid infrastructure, synthesize all of the consumption behavior and patterns, synthesize all of the people, and then we want you to synthesize how they would react and respond under COVID during an outage. And that was a dual disaster environment. And oh, by the way, as we called it, blindfolded and with our hands tied behind our back, we can't give you any access to the data that we have from Salt River Projects, who was our utility partner, because there isn't enough time to get that data through the regulatory process. So this was one of another kind of ways that we spent the pandemic last year, was a true test of how we could synthesize based on publicly available data and then have it validated across the regulatory firewall and create a fantastic space, because now we can work in this environment and we can really accelerate innovation in this environment without, for the utility and with EPRI, without being concerned about privacy issues, about surveillance, about regulatory data. And that, I think, was almost a big advantage for us, was not to be I guess, constrained by that. So now we get to show this environment publicly. We've been in front of the Virtual Resilience Interest Group in the US with the Department of Energy and the Department of Defense and all of the major utilities and national labs in the US. And we get to take it around the world and show people what can be done in scenario-based environments and the value of that data. So that was really cool. Also starting to introduce hydrogen models, because everybody's trying to figure out this technology that may be coming. How is it actually going to fit into our existing infrastructure? Are people going to like it in their gas stoves? How does this fit in, and the economy of it, and when and how should we be making investments in changing our infrastructure to accommodate that? And we won a spot also in the US Air Force's space AF Works Innovation Challenge. So creating synthetic bases and being able to explore with their people, their activity, because every base is really quite different, how they can do things like electrify their fleets to accommodate Biden administration's requirements and maintain resilience. So 99% of them are entirely reliant on grid infrastructure for their power currently, and make sustainability spends and ensure that they have critical operation and mission readiness. So we get to model and play in these environments and really try to figure out the jigsaw puzzle and how that all works, and ensure that they have 14 days of power and water resilience if black sky happens. We also recently finished a challenge, and we're just awaiting to hear the final results in Kuala Lumpur. So with the Toyota Mobility Foundation, we created a synthetic Kuala Lumpur, and we're able to add about 250 models to our modeling catalog around active mobility and micro-mobility, all the way to how people make their mobility choices, we really focused in this project too. We always bring this in, but in this project, it was really important to look at mobility barriers. So look at all different types of marginalized populations, economically marginalized, mobility marginalized, so accessibility, inclusivity, gender issues and distributions, and how people respond differently to safer streets and well-lit streets. And add those all in, and then be able to inflect different types of mobility responses. So wider bike lanes, safer streets, productive train journeys, and calculate right down to, the impact of each individual's trip on GHG emissions, and what policies were going to change their minds. So that was a really interesting project and application. And it's fantastic. People always say, what's going to happen when we build these environments? And we always have a lot of fun saying, we have no idea. Being able to watch, because we validate with the way things are today. And then when you begin to make inflections, you're never quite sure how the population is going to respond. And it's always exciting when they respond, and then we get to validate that with research and with domain experts from what they've seen in other studies. So this is some of what I've discussed already, the dual disaster environment, a little bit more about what these, kind of models and architectures look like, and how we are able to really, rather than be reliant on data, we produce the data. So, we use data, we use research, we use domain expertise. We wrap as many humans into the loop as we can when we create and validate these environments. And then it's really about what are they telling us, and how do we compare different investment choices. We get to watch and play out time, and really be able to understand what is happening to people and investments in technology.
I have a question in the chat from Eleni. If
oh, sure.
Stop. I can read it out for you if you'd like. What is the current process of you making a new synthetic space?
Oh, so the current process is typically we are given an area and a big issue to solve. So, and that's usually where we start, is what entities are involved in it, what other systems are interconnected, and does it affect? And we begin to look at the people, what data we have because that's one of the things that we synthesize, and kind of is the basis of driving the demand against systems that we use is synthesizing the people. We try to bring research around particular entities and areas if we need to change the models or inform the models or add new models as quickly as possible and get that running in the environment. But really our environments are up typically in the first 2 to 3 weeks. And then there's a process of refinement after that, and inflections and results. So this is, I hope I answered your question, Eleni.
3 weeks is amazing. That's pretty darn amazing. Maybe we can talk a little bit more about gory details, but not in the context of this presentation.
Yeah.
Thanks.
Yeah, we call it when we were trying to think, because we have some interface now with the national labs in the US. I think that their cute term for us is like a national lab in your pocket, because we, projects that they take years to set up, we set up in weeks. And that's kind of why we want, and our main purpose is so that actual people can get their hands on this kind of intelligent decision making, and not necessarily have to wait so long and with so many kind of research dollars and applications and large budgets, and make it unaffordable for many. So this is just a reference to what I was talking about of the US Air Force's AFWorks Innovation Showcase, and really being able to look at all aspects of their energy future. we do a lot of reimagining. Everybody's using the term reimagining now, and unprecedented, but that's kind of what we do. And we really think this is just an example of some of the visualizations that we use, because visualizations we think are a really profound part of being able to understand complex data and to make it compelling for decision support as well. And this is the people behind it all. So there's 20 of us now, and we cover everything from mechanical, civil, environmental engineering, engineering project management, comp sci, comp engineering, to 3D animation and design, human behavior modeling, public health and safety. So you name it. I'm missing a bunch. Alternative energy technologists, and then the odd people like myself who are business development. But we've really gone through a series lately of extraordinary wins in the past year, and continuing. That we have 2 that are I can't announce yet, except to say that we're going to space. So, which is really exciting. And this is kind of, I guess, where I'll end, is that that really we're about making these living labs for decision making, for understanding systems and complexity and risk, and in continuing to just kind of add to that model catalog and make that make the future very compelling and very real and very optimizable. Because I think, as we've all experienced an unoptimized future in the last year, there is the potential for the return of intelligence, and that's really what we are about.
Outstanding, Myrna. I'll turn to the audience for other questions, but I also want to thank you for agreeing to be part of the First Jobs program, and to saying that of course you would be happy to take on a student. And could you just give an example of the kind of things students do, university students do, when working with your team?
Okay, so I should have had them here so that they could have talked about it. We are a lot of people's first jobs, and I think that that's wonderful for us, because we do things quite differently, and so, you know, there's a lot of learning when people come to work with us, but usually there is so much kind of diverse research going on that that's a great place for people to start. We also have a modeling process, and that makes it very accessible to people who aren't necessarily even technologists. We have some deep tech stuff going on. So there's always some place for people to find where they are and how they can use their talent and their passion in our company, just because our environments are so diverse. We're extraordinarily collaborative. So as Gail was mentioning before, we are remote first. We were since the beginning, mostly to accommodate people who had kids and lifestyles and sports and hobbies, and a client base that's international. So we have different time zones that we're dealing with, and it just made it so much easier for people to decide whether or not they wanted to work at our office or whether they wanted to work at home. We are now remote completely until the pandemic leaves us. But that's, I think, been a part of developing a really collaborative, the tools to collaborate, the process to collaborate, and being able to do that all online and support people wherever they are.
Excellent. If we could turn off the screen share right now so we could see our audience. And Anna's been very active in the chat with Dean. Okay. So I'll invite Anna. Thank you. Interesting conversation. And then obviously, Anna, you're aware of many things that are going on. Do you have any other questions or comments or insights to add?
Oh, it's a really interesting application area, and the kind of conversation we've had with Dean is very interesting if you want to check it out. But just the tension between having a generic, really applicable, game-changing solution and actually having to find the client that matches that and focus business development efforts and technology efforts to really take advantage of, like, most machine learning works better the more specific the problem is, but this is kind of by construction a general process. So there's interesting tension there on the tech side and on the business development side.
Very cool. Charlene, do you have some interesting resources for Myrna and her team? Do you have any other comments to that?
Oh.
While she's looking for, thank you.
Hi, just making sure I unmute before I talk like a fool. Hi, everyone.
Hello.
So I'm not a computer scientist, but when I saw geospatial in the abstract, I'm like, I gotta come see Myrna's talk. This sounds so amazing. And I remember vaguely last year, there was an article on your company on this very thing. So I'm excited I actually got to see you in person and see your work. So yeah, I'm just really curious how you get your 2D and 3D visualizations. Like, what technology are you using to build the synthetic infrastructure like that? Is so cool.
Our own currently.
Okay, wow.
Yeah,
So it's all custom. Yeah.
Yeah, and there's some stuff that we're working on. I don't know if Dean wants to share. We call it our holodeck, but
Yeah.
but it's complicated. There are a lot of companies who really focus all of their compute on 3D visualization. But the amount of data that we have going on in our environments is just absolutely overwhelming. So, you know, that's where we've had to kind of make our own visualization backend.
Yeah. Yeah. That makes sense. So then you can just tailor it. And so you're focused on just the synthetic infrastructure you need rather than having a bunch of data storage heavy content.
Yeah.
No, this is so cool. I'm glad I came. I have a deadline to work on, but it's like, no, I got to see the talk.
So Myrna, you shared some amazing examples of synthetic cities, but I also know that you've helped companies around the world and locally on synthesizing the use of their technology to establish some quality control, as you mentioned. Can you talk a little bit more about that side of the business and whether that's still of interest? I see that Calvin of IRAP is here. You probably know each other very well, but advising other companies of the strength that your company can complement them with so that they can bulletproof their technologies is always cool.
Yeah, so in the early days, we were focused on digital systems, and just because they were easier to reach out and touch here in Edmonton, and worked with some fantastic companies and still working with some. And really it was around helping their technology experience its future. And so, you know, we even did synthetic lawyers for Deal Closer. We did, which was really fun. But did synthetic for RWIs. We built a synthetic environment of the freeways of North America and the way stations. And we had synthetic trucks with their code in it and synthetic truck drivers interacting with their code. And so they could see what the future of, like, when they were going to onboard 50,000 new trucks in a fleet, what that would look like and do to their system, and figure out what the way station operators were, how their behavior was intersecting with their system. So that, you know, those types of complex environments were where we kind of got our start. And those are still, you know, now when we're working with clean tech companies, we are looking at them more on the side of how do we show the deployment of your technology, de-risk it in the market, show the GHG emissions that you're going to be reducing, and help them at the same time understand, you know, how their technology is going to intersect with people. So we're still at it. But it's in a bit of a different scale, and it's a bit of a different deployment. And sometimes it's just a matter of helping them show their customers, real, true disruptive innovations and what they look like in their customer's city or their customer's deployment.
Wow, so I can definitely see the value beyond the testing, to your point on business development and getting the customer excited about the technology and about the possibilities. Like, I'd say that's even a greater need with my understanding of the technology companies across the province, and they have cool tech, but they need to communicate the values. So well done.
Yeah, and they can actually show it. And then there's fun policy things. So we did masks. We actually put masks on people in Edmonton last March in our synthetic environment and did a commute, and then studied mask efficacy and aerosolized transmission and the effectiveness of masks. So there's policy information as well that we're hoping catches on a little bit more. We'd love to kind of show people what e-scooters look like in Edmonton and the ripple effects and impacts so that they could speed up their little kind of their pilots and understanding of what happens and what happens to people who aren't even on e-scooters, as
like
well as
the word impact,
long-term effects of wastes of the impact. Yes.
Well done, Russ. Actually, Myrna, I'm carrying another quote from you here because I have not heard the quote "fun policy things." This is going to have to be one of your quotable moments. I see Dean has some more comments. Dean, do you want to add anything? We'd love to hear from you. And thank you for carrying this interesting conversation with Anna on the side.
Yeah, that's a good question.
Dean, your voice, your audio is really shaky.
Yes, you do sound synthetic though. So that's
you do, yeah. He is real.
Perhaps the audio is not going to work there.
Yeah, he says I'll have to answer.
That's right. That's right. He can obviously the chat is.
I think Anna had a question about validation and yes, about, because this is something that we always get asked, and this is something that's really important and a huge part of what we're delivering, because we're giving people these kind of glimpses and allowing them to explore things that are unprecedented. So there isn't data. And this is a big part of why we exist. And they have to be certain, and it depends on the decisions that they're making. Some of them are really strategic and big, and like space is really big. And so they need to have that kind of validation with what we're doing. So there is a process, and it typically starts with getting all of the entities in place and the environments up and going and being able to validate against what's happening today. So in Kuala Lumpur, we created the traffic of Kuala Lumpur without any surveillance data or any Waze data or any transportation data. We created the people that created the traffic and made their decisions and choices. And then we validate against what they're seeing. And then we begin to expose and explore, and the knobs and levers, as we call them, and people gain confidence in our environment because they can see some of the changes that they have made and how things react and respond. And then we get to move forward. We get to take those steps forward. And we take every opportunity to involve as many experts and validate against research that we can, because that helps our clients, kind of build their understanding of certainty as well, and inform them in the process.
Outstanding. Clearly your team takes a total systems approach to things, which is so unusual, where there's a lot of knowledge in little pockets and not really not on the total system and the interactions thereof. So when you hire people, are you looking for a total systems thinker, or does it depend on the role? Because you do need those focused experts as well as total systems people. How do you get the total systems woven into things?
That's a great question. And I don't think I've ever asked that of typically what we look for are people who are curious and engaged. One of the number one things is humble, because you can't know it all. You can't come into our company knowing it all. That's why we, kind of approach the world in awe, and how we get to collaborate with so many other people is through that humility and the amount and type of learning that we have to do every day in sectors that we have absolutely no knowledge of, that we get pulled into, requires that type of humility, and then just, kind of counterbalanced by insane, curiosity, and then all kind of scoped into productivity, because we are not VC funded, we're revenue funded. And so we have to eat our value. So we have to be always kind of conscious of delivery and productivity and value.
Outstanding. And the fact that you aren't, that you are revenue customer funded versus grant funded. So outstanding.
We have some grants.
Understood.
Yes,
but you're providing.
But we haven't gone the VC route. Yeah.
Oh, sorry. You're right.
Yeah.
You're right. The investors that VC is a pro and a con, right? It's great to have the investment, but it does, the control is no longer with the founders. Now there's this separate element that has artificial deadlines, if you will, that may not be appropriate for the company. So there's a strength and a challenge with that VC approach, right?
Yeah. And I don't know if they would have been as patient as we needed to be with this technology to explore it in the way we have, and to be where we are. It's been 7 years. So,
which is what you've accomplished is fantastic. I know that Sabina had told us that she had a 1 o'clock meeting that she would need to leave. So she's leaving the Zoom on for us. I know that there was, oh, there she goes. I have to, her comment on the side. Niraj will be here to wrap up the seminar. That might be Niraj's cue. Over to you.
Yep, I'm here. Thanks, Myrna, for a fantastic talk and for an engaging discussion with Anna. Thanks, Dean, as well, for answering most of the questions, and that was really wonderful. We thank Myrna for a wonderful talk, and Gail for introducing her and bringing her to the AI seminars. If you have any questions or you want to get in touch with Myrna, there is a sheet for one-on-one meetings, and you also have that contact information available. If you need, feel free to ask me or directly write to Myrna or Gail. And we'll be looking forward to next week's seminar, and we'll meet, possibly meet you next week. Thank you once again, Myrna and Gail and Dean, everyone. Thank you so much.
Our pleasure. I know that Sabina had a sign-up session that they wanted to talk to Myrna afterwards, so I'll leave that with you and Niraj to manage. Also, Justin Stevens, and a bachelor's of science grad and incoming master student and founder of the undergraduate AI club, is now going to be helping me select companies for the coming once a month for the rest of the year. So we are working on other cool companies. This is going to be a hard act to follow, Myrna, but really, really love what you're doing and how you're doing it. And thank you so much.
Thanks, Gail. Thanks,
everyone.
Thanks everybody for listening.
And last comment regarding the recording, we'll upload these recordings on Amii's YouTube channel, and you'll be able to access that soon.
Perfect.
Thanks, everyone.
Bye now.
Bye-bye.
Thank you.